Okay, let's go over the review for the semester exam. All right. All right, number one. What is the domain for the graph? So if we look at the graph, the domain, we know this is the x values. So if these go by 1, the x values start at 2. It's a lot easier to do the interval notation first, I think. So since it starts at 2, and notice how it goes towards infinity. The arrow implies, oh, you can't see. Oh, yeah. The arrow goes towards infinity. So the domain are all the x's in this direction, right? Starting at 2 and greater than. So 2 to infinity. For inequality notation, this is with the greater than or less than. We want everything that's greater than 2. So x is greater than or equal to 2. All right, number 2. What's the range? The range is all the y values. And it starts at 3 and goes towards negative infinity. So okay, so 3 to negative infinity. Negative infinity has to be on the left. So negative infinity up to 3. And inequality, we want everything smaller than 3. So y, right, because range is the y values. This is less than or equal to 3. Okay. All right, number 3. Matrices. We haven't talked about this in a while. So 3 by 3 system of equations. What is the coefficient matrix? So the coefficient matrix, hence the name coefficients, it's all the numbers in front of the variables. Right, everything that's in front of the variables in order. So it's going to be 2, negative 1, 4. Negative 1, 3, negative 2, 4, 2, 3. So all we did was just write the coefficients, right, in a matrix. Okay. Constant matrix. The constant matrix are the numbers to the right of the equal sign, again, in a matrix. So this is going to be one column with 3 rows. 19, negative 7, 37. Okay, word problem. So what do we ask to do? Read the word problem, set up, rearrange so the variables line up. So basically, our answer is going to look like what it was in number 3. Okay. High school's enrollment is 500 students. It includes freshmen, juniors, and seniors. So freshmen, juniors, seniors. So we have three things. When we add them up, the total needs to be 500 because that's what it says. The school's enrollment is 500 students. So this is going to be, we'll just call it X, Y, and Z, right? So, I mean, we call it whatever you want, but X, Y, and Z is typically what we use. So X plus Y plus Z is equal to 500. Okay, now twice the freshman enrollment. So twice the freshman. Twice means double. So 2 times. 2 times whatever a freshman is, which is X. Is, that's a key word. That means equals. Is what? 3 times the senior. So 3 times Z is 3 times Z equals 3 times Z. So equals 3 times Z. Okay? The total number of juniors and seniors. So juniors, seniors. So Y and Z is what we're talking about. The total number of Y and Z. So that means Y and Z added together. So Y and Z added together is equals what? 200 more than the number of freshmen. So you have the number of freshmen and 200 more. So plus 200. So X plus 200. X plus 200. Okay, you might have to listen to that reasoning a couple of times. But just remember, when you see is, that's a keyword. Is an equal sign. So let's rearrange this so that X, Y, and Z are all on the same side. So the top one, that one's already good. X plus Y plus Z is equal to 500. Okay, the second one, we have 2X equals 3Z. Okay, well, I need the 3Z to be on the same side as the X, so I'm going to subtract it. So minus 3Z. Not only that, but I'm lining it up with the other Z variable. Let's notice that there is no Y variable, so I'm just going to put a 0. And then when we move the 3, there was a 0 left. Okay, the bottom one, Y plus Z. So I'm going to line up Y and Z. So Y plus Z is equal to what? X plus 200. Okay, well, I don't want the X to be on that side. I'm going to subtract it over. So to the left side. So minus X. And then 200 is left. All right, and this would be the coefficient. This would be the matrix that we would work with. All right, number 5. Use the following quadratic to answer some questions. Okay, up or down? Well, A is -4, so down. Dilation. The dilation is the number 4. Do I really care about the negative sign in the dilation? No, not really. It's just the number. And what are the x-intercepts? Okay, so the x-intercepts, keep doing it. X-intercepts are these guys. And we know that the inside lies. That's what we say. Right? It's the opposite of whatever you see inside the parentheses. So the x-intercepts are x equals +7, x equals +9. Okay. All right, these are important. Number 6. Are the following points a solution to the graph? Yes or no? Okay, so what we're looking for is shaded and solid areas. So what do I mean by shaded and solid? Example, this would be on the shaded and solid. This is just solid line, right? So maybe we should say shaded area and solid line. So shaded area and solid line together at the same time, right? Not just one or the other. Well, I'll take that back. If it's in the shaded area, that's good. But that's a solution. But we need if it starts to get on the edge of the shaded area, well, when you're on the edge of the shaded area, it needs to be on a solid line. That's what I'm saying. That's what I'm saying. So dotted line is not a solution. So not on the dotted line. All right, so let's see. So -2, -1. -2, -1. Right away. This is in a dotted, right? It's touching the shaded area, but it's on a dotted line. So that's a no. 1, 1. So over 1, up 1. Hey, look, that's, yes, that is, because it's in the shaded area, but it's on the solid line. So yes, that is a solution. 2, 2. 2, 2. It's nowhere near. So no. I'm running out of colors. Let's go yellow. So 0, -1. 0, -1. All right. Shaded area. And it's on a solid line that's touching the shaded area. So yes, this is a solution. And then finally, -1, 1. So -1, +1, black dot. It's in the middle of the shaded area. So yes, this is definitely a solution. So again, big takeaway, shaded area. And if it's on a solid line, the solid line must be touching a shaded area. So the big thing here is dotted line. For sure, dotted line is not a solution if the point falls on the dotted line, even if it is in a shaded region. All right. Number 7, solve, find the roots. Okay, this is, I feel, where most people are going to struggle. Or depending on what teacher you have, you learn different ways of factoring. One method, we say the slide and divide method. Well, first off, I noticed that the coefficient in front of x squared is not 1. Okay, so I just can't factor this by looking at it. I have to do something to it. So I need this to be a 1. Basically, I need the 3 to go away. Where do I need it to go to? We multiply it times -5. That's the technique that we teach. So 3 times -5 is -15. Then minus 14x, x squared. Notice how I'm writing everything in descending order. X squared, then x, and then just the number. Okay, so this is the quadratic that we want to look at. So notice x squared, the coefficient is 1. So this is what we were trying to make. So I want to factor this, come up with 2 numbers that multiply to make -15. Now, I know a lot of people struggle. I'm like, well, what number goes on the bottom and what number goes on top? Really, it doesn't matter. Like, who cares what number goes where? That's like my opinion on that. What matters is that we need to come up, i.e. you need to come up with a number, 2 numbers, that when you multiply, they make this number, C, the C value. At the same time, they need to add up to whatever the B value is. So 2 numbers that multiply to make -15 that add up to -14. Doesn't matter what number, like I said, it's all technique, right? Like the X that I'm making on the side with the 2 numbers. It doesn't matter what number goes where. What matters is that 2 numbers multiply to make -15 that also add up to -14. So I personally put mine on the bottom so I can put or the -15 on the bottom so I can put my little T chart the way I'm doing right now. If the numbers were switched, it wouldn't matter, but I wouldn't be able to make my little list that I'm making right here. So 1 and 15, 3 and 5. These numbers multiply to make 15 all day. But I need it to make -15. So one of them needs to be negative. Well, is it the 1, the 15, the 3? Like, is it the smaller number or is it the larger number? I have to look at what it has to add up to. Since it has to add up to negative 14, the big number needs to be negative. So 1 plus negative 15 does equal negative 14. This is the one that adds up to negative 14. So what do I do with 1 and 15? Negative 15. They go right into factors. X plus 1, x minus 15. Okay. So what are we looking for? Find the roots. Where does it cross the x-axis? That's what this is saying. So here are the factors. But this is the most forgotten about part in the technique, is that because we slide and divide, because we slid the 3 over to make negative 15, here we have to remember to divide the 3 out. That's the most forgotten about part. So the roots are going to be, inside lies, x equals negative 1/3, and 15 divided by 3 is 5. So x is equal to positive 5. Those are the roots. So factors, roots. Okay. You could write it in the box. I wrote my answers right there. All right. Use the quadratic formula to find the discriminant. Okay, there's a fancy word. So the discriminant. What's the discriminant? So let's talk about that before we finish this question. So the discriminant is part of the quadratic formula. All right, so is the quadratic formula written anywhere? No. All right, check it out. Quadratic formula says all right, if you have a quadratic, x is equal to negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a. And the discriminant is this part right here. Just the part under the square root. So we don't want the square root. We want the part inside of the square root, aka the radicand, if you know your terminology. The part inside the square root at the end of the day. Okay. That number will tell us something about the types of solutions. There are 3 types of solutions, right? Because there's basically 3 types of numbers in terms of the discriminant. It's going to be a positive number, it's going to be exactly 0, or it'll be a negative number. I'm talking about the part inside the square root. So if the part inside the square root is positive, right, a positive number, 1, 2, 3, 4, whatever positive number there is, this means there's 2 real solutions, SOL solutions. Or this number could be 0. Then it's 1 real solution. And then lastly, this number could be negative, right? You could get a negative number. If the 4ac part is bigger than the b squared part, right? You have a small number minus a large number. Well, if it's negative, you have 2 imaginary solutions. Imaginary solutions. If this is multiple choice, just know that imaginary numbers always come in 2s, right? The i's always come in 2s, right? You have 2 i's. So that's how I remember that. It'll never, ever be just one imaginary number. Okay, so let's start solving this thing. So first step is to rewrite it so that it's all the terms are on the same side. So x squared minus 2x plus 8 is equal to 0. Okay, what happened? Where did negative 2x come from? You have to ask yourself. Right, it's positive up here, but I wrote negative. Why is that? Because I moved it to the other side. So that it's to the left side, so that all the terms are aligned up. Okay. The a value is 1. Not x squared, but the number in front, 1. B is negative 2. Not negative 2x, negative 2. C is 8. So when I plug these into the quadratic formula, I should get negative, because that's part of the formula. B is negative 2. Okay, negative 2. Plus or minus the square root of b squared. Okay, notice b squared. I have to put b in parentheses. Why do I have to put b in parentheses? Because if you're watching this, you're probably going to be using the calculator or Desmos or some sort of tool. If you don't put the parentheses, the calculator doesn't know to square the negative. It's only going to square the 2, and your answer is going to be all jacked up. So negative 2 squared in parentheses. Right, the negative 2 in parentheses. Minus 4ac. 4 times a, which is 1, times c, which is 8. All over 2 times a. There's the quadratic formula. This, if we simplify it, it'll give us the solutions. So if we start simplifying, we get 2, right, because negative times negative, plus or minus the square root of what? 2 squared is 4. Negative 2 squared is 4. And then 4 times 8 is 32. All over 2. This simplifies one more time. 2 plus or minus square root. 4 take away 32. Negative 28. All over 2. All right. Couple things here. The discriminant is just the part inside. So before we did anything, the discriminant is negative 28. That tells me that it's going to have 2 imaginary numbers, or 2 imaginary roots, rather. And finally, what are the solutions? Okay, well, technically we're at the solution. 2 plus or minus the square root of negative 28 over 2, right? At the end of the day, that's the solution. But that probably won't match any answer that you're looking for, and there's no way to put this into a calculator because it has an imaginary number in it. So let's simplify this one more time. Okay, the negative, that's going to come out as an I. Then 28 can be broken down to its prime numbers. 2 times 14. 14 is 2 times 7. Here's a pair. Remember that? Pairs come out. So then final answer, or not final answer, second to final answer, 2 plus or minus 2 comes out. There is an I. And then the 7 is left behind. All over 2. Notice 2. 2, 2, and 2. These can be canceled. You can cancel these out. Only because all 3 terms have something in common, right? The GCF, greatest common factor, is 2 in this case. So 1 plus or minus I root 7. Why did I write 2? All over nothing, right? Because the 2 in the bottom canceled. So the solutions, 1 plus or minus I root 7. Okay. Moving right along. I said all I wanted to say on that one. All right. Number 9. Give the vertex of the following equation. Too easy. The x part of the vertex is right here. Inside lies. So the x part of the vertex is 8, positive 8. The y part of the vertex is outside. So this is the x part, y part of the vertex. I mean, technically it's like the coordinate, but you understand what I'm saying. The x part of the vertex, y part of the vertex. So final answer, 8, comma, 17. Okay. Give the vertical dilation and y-intercept. Okay. So this is testing our knowledge of if we can interpret these things. So the dilation is just the number right in front of x squared. Just the number. So does yellow show up? Yeah, it does. So 4. Well, I don't care about the negative 4. Negative means it opens up or down, but it's stretched by a factor of 4. The intercept, y-intercept, is the c value. So 8, positive 8. I'm craving for McDonald's all of a sudden. Yellow and red. All right, number 11. Write a quadratic equation in standard form having x-intercepts negative 6 and 7. So we take the x-intercepts, x equals negative 6, x equals 7, right? Because these are the x-intercepts, they're the roots. So we have to start with those. That's all we have. Then I turn these roots into factors. Factors are going to be inside lies. So x plus positive 6. Because it equaled negative 6 as a root, when you change it to a factor, you switch the sign. X minus 7. All right, so those are my factors for an equation that has roots negative 6 and 7. Okay, we want it in standard form, like right here. So this is what we want, okay? This is what I have, x plus 6, x minus 7. We have to start FOILing this out, so let's expand it out. X times x, x squared. Notice, I draw my arrow, and then I do the math. So x times negative 7, negative 7x, 6 times x, plus 6x, 6 times negative 7, negative 42. We can combine something in the middle. So negative 7 plus 6. So this is going to be y equals x squared minus what? Minus 1, x minus 42. Okay. Describe the translation. Nope. Absolute value graphs are V-shaped. Okay. Basically, it looks like this guy right here. All right, what's it going to do? Inside's going to lie. So the inside part, this is going to shift. Which direction? Opposite of what we think. Left 4 units. The outside part, it's my vertical movements. So this is going to shift everything down 6 units. So left 4, down 6. There's no other transformations happening. Okay, 13. Use the parent function to transform the graph. Okay. All right, so here's my graph on the right. The parent function. So what you see is the parent function. What we want is to take this equation, extract all the information, all the movements, and then apply it to this. So there's a couple things going to happen here. A few things, actually. So this is going to go, like we just talked about it. This is going to move left. This is going to move it up. Why do I write my U like that? Up. The negative is going to reflect it down. Reflect. And then the 2 is going to stretch. So there's a lot of things happening. Not stretch left. These are two separate things. Okay, so let's start with just moving the vertex. The new vertex. Where's the new vertex going to be? The new vertex, well, here's the vertex. The old one. And we're going to move it left 3, up 4. So left 3, up 4. 2, 3, 4. Okay. So the old vertex, there's the new vertex. Instead of opening up, it's going to open down. And it's going to stretch it by 2. So notice in the parent function, it goes up 1 over 1, up 1 over 1. Okay. What we're going to do, it's going to go over 1, down 2. 1 is going down because it's negative. But over 1, down 2, over 1, down 2, right? Because that's what the slope is. The slope is 2. I'm sorry. It's going to go up or down. So it's going to go down. And then 2 over 1. Yeah, 2 over 1. Down 2 over 1. Sorry. So down 2 over 1. Down 2 over... I'm going to get rid of this one so it's not confusing. So notice down 2 over 1, down 2 over 1 the other direction. And then connect the dots. Okay. All right, let's answer some questions. Well, describe the vertex or describe the transformation. We just said it. It reflects it. It stretches by a factor of 2. It's shifted left and up. So new vertex we said was at negative 3, 4. The domain, negative infinity to infinity. Or you could say all real numbers. All real numbers is an answer also. All right, range. It's going to go from negative infinity up to the y part. All right, number 14. Write an absolute value equation to represent the graph below. Okay, so this is like going in reverse. So here we have the picture. We need to figure out where the equation makes this graph. So I know that in general, absolute value of x, right? That's the parent function. That's what this looks like because it's a v. Okay, the vertex is at 1, 2. So the parent function starts at 0, 0. And it moved. How did it move? It moved to the right 1 and up 2. So this is the parent. Then we did to the right. So x minus 1 and up 2. Okay. Now, normally it goes Up 1 over 1 from the vertex. Up 1 over 1. Up 1 over 1. That's the slope. But it's not doing that. It's going up 1 over 2. So 1 over 2. There it is. That's the absolute value equation. Sorry. Excuse me. Okay. Number 15. We're solving an absolute value. So there's a hint here. Must have 2 answers. Okay, so that's telling me something. So how do I get 2 answers? That's the question. And it comes from splitting this into 2 equations. So now once I break it into 2, we don't need the absolute value bars any longer. So 2g minus 9 is equal to 11. That's 1. Then 2g minus 9 is equal to negative 11. So notice the negative sign here. Right? We have a positive one and we have a negative one. Now, we can only do this when the absolute value is the only thing on the left. So notice here, it's just absolute value with some stuff inside of it. That's when we can split it into 2. Had this problem had a whole bunch of crap like around it, right? Then there's like, you can't break it into 2 right now. I mean, I could, you cannot. So you have to move everything to the right to isolate the absolute value so that it's just the absolute value. Then and only then can you split it into 2 different equations, right? So don't try to split it into 2 when there's things outside the absolute value. That's the point I'm trying to make here. All right, now that we have our 2, we just solved. This is 1 variable equations, right? So we're going to add 9 to both sides. So 2g is equal to 20. Divide both sides by 2. G is equal to 10. So one solution right now is 10. Let's check it. 2 times 10 is 20. 20 minus 9 is 11. Absolute value of 11 is 11. Okay, so that works. Let's try the next side. Plus 9. Plus 9. Okay, I know this is where we struggle. Negative 11 plus 9. So when you're trying to figure out how to add and subtract negative numbers with positive numbers, just imagine a number line, right? Negative 11 is right here. I want to add 9 to it. So adding 9, right? That's what it means to add something. You move to the right. So then this would be negative 2. Divide both sides by 2. And g is equal to negative 1. Right? Negative 2 divided by 2 is negative 1. Let's check our answer. 2 times negative 1, negative 2. Negative 2 plus negative 2 minus 9 is negative 11. Absolute value of negative 11 is positive 11. So both of our answers work. All right, moving on. We're more than halfway. All right, number 16. Simplify I to the 22nd power. Okay. This is 2 different ways of doing this, depending on how comfortable you are with numbers. First off, we need a list. So if you go back and watch the video, we have a very particular list that we use that involves the powers of I, imaginary numbers. So I to the first power is I. I to the second power is negative 1. I to the third power, negative I. And then I to the fourth power is positive 1. Then the list repeats. I to the fifth power would be I. I to the sixth power would be -1, right? Like it just keeps cycling through. So one way you could do this would be, since I know I need 22, I mean, we could sit and count until we hit 22. That's a way of doing it. I'll let you do that right now if you want. Or if you know how to count by fours, 4, 8, 12, 16, 20, and then 2 more. Or if the number is really large and you can't count to it, then what you would do, the preferred method, is to take whatever power it is and use long division and divide it by 4. So 4 goes into 22 5 times. 5 times 20. 5 times 4 is 20. Subtract 2. The remainder, right, because 2 doesn't go into 4 anymore. So it's a remainder. This is the new power. Meaning it's equivalent to whatever power you were analyzing, right? So right now we're looking at I to the 22nd power. Okay, well, that's going to be equivalent to I to the second power, right? This is equivalent to I to the second power because the remainder is 2. So what is I to the second power? Oh, it's -1. Okay. Multiplying and adding, subtracting complex numbers or imaginary numbers. Numbers involving imaginary numbers, complex numbers. Okay, so here we have 2 parentheses right up against each other. So this is multiplication. You have to multiply here. You don't combine like terms, right? If this was a plus or minus, then yes, you would combine just the like terms, but it's not. We have to multiply. So again, draw the arrow, do the math, right? This is basically FOIL. I mean, it is FOIL. First is 4 times 2. 4 times 2 is 8. Outer, again, draw the arrow, do the math. 4 times 3 is 12, but there's an I involved. Inner, draw the arrow, do the math. -3 times 2, -6, I. And then last, draw the arrow, do the math. -3 times 3, 9, I times I squared. Okay, first off, we can combine like terms right here. 12 minus 6. So we get 8. 12 minus 6. So it's going to be positive 6i. All right, let's talk about this. Minus 9i squared, right? The I squared, we just said in the previous problem, is equal to -1. So I squared is basically -1. So what is -9 times -1? Positive 9. Anytime you have I squared, all it's going to do is change this sign. That's literally all it does, right? Because it's -1. And then last step, we can combine 8 and 9 to make what? 17? So 17 plus 6i. Typically, you write the I second. Okay. 18. So we're subtracting now. Hint, distribute the minus sign first. Right. Because it's being subtracted. We're not doing what we just did with FOIL. We're just subtracting. So, I mean, you don't even necessarily need to do the hint, really. 4 take away 2, -3 take away 3. The hint really helps out because most people can't handle negatives correctly. So when you distribute the negative, this is going to be -2 minus 3i. And then in the front, minus 3i, 4. Like, I don't even need the parentheses in the front one. Because we're just adding at this point or combining. So look, 4 take away 2. Okay, that's 2. Negative 3 minus 3, negative 6i. Right, negative 3 take away 3. All right, 19. Again, we're adding. So I'm going to distribute the 5 first, kind of like we did in the last problem, just to get it out the way. Plus 15. All right, 5 times 2, 5 times 3. You could multiply it out. All right, and then again in the front, you don't really care about the parentheses there. All right, let's combine some things. What are alike here? Whole numbers. 4 plus 10, 14. Negative 3 plus 15. So negative 3 plus 15, basically 15 take away 3, positive 12i. Okay. What is the vertex form of this? Okay, so it's in standard form. We need it in vertex form. There's multiple different ways of doing this, I guess, but what this is, well, it's telling us which way to do. So completing the square, that's what we have to do. That's the instructions right now. All right, so this is a very specific process that has to happen. So step 1, take half of b. Okay, so hold on, let's back up. Before you do step 1, you have to make sure that x squared is 1, and it is. So I can do what I'm about to show you. If it wasn't 1, if it was a number there like 2, 3, 4, 5, or some number, then something else would have to happen first. But we're not going to cross that bridge just yet. All right, so it's a 1, so I'm going to continue through with the process. The first step is to take half of b. Whatever b is, you take half of it. Okay, so let's do that. What does that mean? That means, what is b? B is 10. So 10 divided by 2, that's equal to 5. So that's step 1. Step 2, whatever number you get, you square it. So what did we get? We had 5. So therefore, 5 squared. What's 5 squared? 25. Good job. Okay, so this is all we need. So now, here's the setup. I'm going to rewrite the problem. This is x squared plus 10x. Watch this. Plus something minus something equals, plus 6, right? Like all I did was insert something in between the 10x and the 6. I'm adding something, I'm taking something away. Plus 6. And what do we add there? That's the question. Okay, so watch this. So when we squared it, I want to get my colors right so you can see it. So when we squared it, 25, that's the number we add to the blanks. Okay, the beauty of this is that, without going into detail, again, there's another video on it, the first 3 terms are guaranteed to factor into this number, right? Whatever that number is, 5, positive 5, that's the number that goes here. And then combine whatever's left out here. Negative 25 plus 6. So negative 25 plus 6, negative 19. And there's my vertex form. So take half of b. First off, There needs to be a 1 in front of x squared. Then take half of b. Put that like on the back burner because I know I'm going to need that number later. We square it. We came up with 25. That's the number that you add and subtract from the original equation. And the first three terms, and it's always plus first. The first three terms are guaranteed to factor into whatever the number is that when you took half of b. So x plus 5 squared. And then combine the two terms on the outside to make negative 19. All right, that's the vertex form. So y equals x plus 5 squared minus 19. What is the vertex? Inside lies negative 5, negative 19. Okay. Let's cross the bridge of when a is not 1. All right, so let's do this. So there's a couple different ways depending on what you had. So like right here, look, hint, a is greater than 1, right? It's not 1, so we got to do something. So depending on what teacher you had, there's different ways of doing this. So I'm just going to go through what I know. All right, so I'm going to rewrite the problem. But first, I need to factor out, like I need there to be a 1 in front of x squared. Right? This 3 is messing things up right now. So watch how I do this. All right. Y equals what? 3. I'm going to factor out a 3 from the first two terms. So x squared minus 24 divided by 3 is 8. 8x. Right? Because if I were to put this back in, I would get those first two. Now, the plus 91, that guy's out here. Like, I don't really care about that right now. Okay. I'm going to add something, take something away. Right? That's the process. Add something, take something away. Now notice in what we've done. I factor out the 3 so that x squared is has a coefficient of 1. So really, for the moment, I don't really care about none of this. Right? I'm just looking at what we made in the middle. That's literally what we did in the last problem. I just factored out a 3. Like whatever that number was in front of x squared, that's what you're factoring out. All right, moving on. So run through our process. Take half of b. Okay, what was half of b? Well, b was negative 8. I'm taking half of it. So this is negative 4. All right, that's my number that I'm going to put on the back burner for later, right? Because that's going to show up down here, right? X minus 4. So just know that's going to come up later. All right, then I square this number. So negative 4 squared, that is 16. So then we add 16, and then we subtract 16. Okay, let's do some work here. So then the first 3 terms, x squared minus 8x plus 16. I already know, I already got it. It's this right here. It's that right there. I'm just going to rewrite it again. Okay, so how does everything else fit into it? Check it out. So y equals 3 times what? X minus 4 squared, right? That's the part that we just had. Minus 16, right? Because that part was still outside. And then close parentheses, plus 91. We're almost done. All right. What I need to do is distribute. So this is going to be 3 times x minus 4. Notice I didn't distribute the 3 into the x minus 4 because you can't. There's a square there. Like the square is like stopping things from going in. And then 3 times negative 16. Okay, 3 times 6 is 18. Carry the 1, 48. And then plus 91. So you can see when the coefficient is 1 from the jump, this problem is so much easier. But when it's not 1, it's very involved. So final answer, we just have to combine negative 48 and 91. So this is going to be 3 x minus 4 squared. Okay, 91 take away 48. Who remembers how to do this? 9, 10, 11, 43. So positive 43. Vertex form, I just wrote it. There's the vertex form. The vertex we can extract from this is going to be 4, 43, right? Inside lies, and then the outside is what it is. It is what it is. Okay. How much more we got? Oh my goodness, 2 pages. All right, 22. All right. Sorry. Throat's all acting up. Simplify. All right. In Algebra 2, we teach that we don't like square roots in the bottom of a denominator. Big picture, I don't really care. But in Algebra 2, we don't want square roots in the bottom. So that's what we're going to do. We're going to get rid of the square root in the denominator. So first off, if it was just this, you're going to multiply by whatever it is in the denominator, right? If this was the case, this would be easy. This would be 6 root 5, 5, right? Because root 5 times root 5 is just 5. And then we would be done. Okay. That's not what we're doing. What we're doing is 2 minus root 5. Just want to make sure. Oh, I stepped on the toes of the next question. All right, my bad. We should have led with that one. But anyways, I need to multiply by something top and bottom. That's the point I'm making. What do I multiply by? The word conjugate. The conjugate of what we have, 2 minus root 5, is going to be 2 plus root 5. Notice what changed. 2 plus root 5. 2 plus root 5. Top and bottom, right? Because this whole value, anything divided by itself is 1. So I'm just multiplying by 1. I'm not changing its value. I'm just changing the way it looks. Okay. The beauty of multiplying by the conjugate is that this is multiplication. So you have to FOIL things out. But because it's conjugates, we don't have to FOIL things out. What we do is we take the first times the first. So 2 times 2, 4. And then the last times the last only. So negative 5. Well, that's kind of nice. Because 4 minus 5 is just negative 1. And then up top, we have 6, 2 plus root 5. I'm going to leave the 6 out just in case, something happens and it can cancel. In this case, it's not. But our answer, final answer, I'll work down, is going to be 6, 2 plus root 5 over negative 1. All right, the over negative 1 is just going to change. What's it going to change? So negative 6, 2 plus root 5. Well, there's a couple of different ways you could have done this. It's going to change the 6 to a negative 6. And, that's pretty much the answer. That's simplified. If you want, you could distribute this. Whatever. negative 12 minus 6 root 5, right? But that's simplified to me, right? It's factored out. Okay, 23, like we were just saying. I need to multiply this to get rid of the square root in the denominator. I'm going to multiply this by something. What am I going to multiply it by? The thing in the bottom. So root 2, top and bottom. Again, this is just 1, right? I multiply anything times 1. I'm not changing its value. I'm changing the way it looks. Okay. Here we go. Top times top. So 8, 10. Where'd 10 come from? Because when you're multiplying square roots, it's the inside times the inside. 5 times 2 is 10. Right? Inside numbers and outside numbers can't multiply. Right? Outside coefficients and radicands can't multiply. So you just multiply the inside and then whatever's on the outside. All right. Then you try to break 10 down if possible. Well, 2 and 5 are both prime numbers. 10 doesn't break down anymore, so we're good there. Then, on the bottom, root 2 times root 2 is 4. Square root of 4 is 2. So root 2 times root 2 is just 2. That's actually really nice because, look, these are going to cancel. 8 divided by 2 is 4. Root 10. Final answer. Okay, find the discriminant and state the type of roots. Oh my goodness, we had this in the earlier. Like, this is literally what we did on the front page. Look. Number 8. That's what we just did. Is it worth doing it again? Okay, the only difference here is that the equal sign is like in the middle of the equation. So you just have to move everything, right? Move everything this way. So minus 4, doing the opposite, minus 6. So minus 4x minus 6. So we're getting 3x squared minus 4x minus 6 equals 0. Looking at the determinant, remember what the determinant was, or not the determinant, the discriminant, sorry, multivariable in my mind. The discriminant is going to be b squared minus 4 times a times c. The reason we moved everything was so that we could identify the a, the b, and the c, right? You couldn't do it before because there was on the wrong side of the equation. All right, so get out of here, Land O'Lakes. All right, the discriminant. Let's calculate this thing. So negative b squared minus 4 times a times c. Right, that's what we said. B squared minus 4 times a times c. Oops, that's a c. All right. So what do we got? Negative 4 squared. Negative 4 times negative 4 is 16. Okay, there's a couple of different ways of doing this, but this is just subtraction and multiplying negative numbers. So it's not 16 minus 4, right? That's not what this is saying. This is saying 16 minus 4 times 3 times negative 6. So what I do is handle the negatives first. So negative times a negative is a positive. 4 times 3 times 6. Okay, how do you want to do this? 4 times 3 is 12. 12 times 6 is 72. 12, 24, 36, 48, 60, 72. All right. So 16 plus 72 is 82 plus 6, 88. Hope that's right. So the discriminant is 88. Which category does this fall into? Is it equal to 0? No. Is it bigger than 0? Yeah, it is. 2 real solutions. So that's 2 real solutions. All right. Remember, the discriminant is the part inside the square root. We don't care about the square root. All right, 25. Sketch the parabola on an XY graph for each solution. Okay, too easy. One real solution. Here's my Y, here's my X. One real solution is going to look like this. That's what it means, right? It touches the x-axis only once. It bounces. This is when the discriminant is equal to 0. Is when you get this scenario. For two real solutions, again, x and y, two real solutions, meaning it crosses the x-axis twice. This is the case that we just had above, right? Here we had a discriminant of positive 88. That whatever formula equation it comes from will have two real solutions that look like this. I mean, more or less. All right, and then two imaginary solutions. So let's do it in, wow. All right, imaginary solutions means it doesn't cross the x-axis ever. It could even be down. It just doesn't cross. That's what it means to be imaginary. Anytime you do the quadratic formula and you get an I under the square root, this is what is happening. This scenario right here, one of these two, not at the same time. All right, 26. All right, 26. Solve this quadratic. 36x squared plus 25 equals 0. Okay. It's a quadratic at the end of the day, right? So the quadratic formula would work, but you don't need to do the quadratic formula. Only because there's no x term in the middle, right? You don't have a b value. Well, technically it's 0, but that's like way too much work. Just isolate the x. Minus 25. 36x squared is equal to negative 25. Divide both sides by 36. X squared is equal to negative 25 over 36. Take a square root of both sides. Don't forget about plus or minus. This is nice because a couple things. There's a negative under the square root, so that's going to come out as an I. So I know my answer has an I in it. And then take a square root of the top, square root of the bottom. This is nice because what's the square root of 25? 5. What's the square root of 36? 6. And then we have plus or minus in front. Now, if those weren't 25 and 36, like there would be some work to do, but you know, let's just be happy that perfect squares showed up. Okay, what do we got? Last page, 27. All right. Graph. It's a quadratic. So let's graph the quadratic. What form is it in? What form do you think it's in? What is the vertex? We'll call the trick. Okay, well, I don't necessarily need the trick right now to find the vertex. The vertex is at negative 2, 3. So negative 2, 3. So there's the vertex. I know that the axis of symmetry goes through the vertex, right? Those things are connected. So x equals negative 2. So there's my axis of symmetry. Like the points will reflect left and right of this thing. All right, does it open up or does it open down? Well, I know that it opens down because the a value is negative. So it opens down. It opens down. The dilation is 2. So by a factor of 2. The y-intercept we'll get in a minute. Domain and range. I mean, I could answer that right now. Domain is going to be all real numbers. Right? Every quadratic's domain is all real numbers. And then the range, since it opens down, it's going to come from negative infinity and go up to whatever the y value of the vertex is. In this case, we know that it's 3. Okay, so now, I mean, to be quite honest, do I really need to graph it? Yeah, because I need to find the y-intercept. Okay, so now let's recall the trick because we need the points. Okay, the trick, 149, right? Whatever distance I go over, okay, whatever distance I go over corresponds to one of these values, right? 149. The reason I say 149 is because from the axis of symmetry, from the vertex, if I go over 1 unit, then I'm going to go down 1 unit. If I go over 2 units, y squared 2 squared is 4, so I go down 4. If I go over 3 squared is 9, so I go down 9. If I go over 4 squared is 16, I'd go down 16, right? There's a pattern here. This pattern is only valid when a is 1. Is a 1? No, it's not. A is 2. In fact, it's negative 2, which just means I'm going to go down. So what that means is I have to double my distance. So instead of 149, it's going to be 2, 8, 18. I won't even get to the 18 because I don't even have that many spots on here. So if I go over 1, I'm going to have to go down 2. If I go over 2, I'm going to have to go down 8. 1, 2, 3. And then if I go over 3, I got to go down 18. But again, 18 is going to be off the map. So I don't really care about that. So you might have to rewind that a couple times. But 149, that's the trick that it's referring to. Right? Whatever distance you go over 1, 1 squared is 1. That's how much you go down. You go over 2 squared is 4. That's how much you go down. But that works when a is 1. When a is 2, it's basically the same thing. You're just doubling those numbers. So if it was 3, you'd triple the numbers. If it was 3, it would be 3. 4 times 3 is 12. 9 times 3 is 27. Right? Like, so a is equal to 1, a is equal to 2, a is equal to 3. Right? These are the distances that you're going down. All right. I guess I beat that up. So we can reflect all these points over. The big point is that, or the major point is that I want the y-intercept. That's the whole purpose of doing what I was just doing. Otherwise, we would have just moved on to the next problem. So I needed the y-intercept, which was negative 5. We did all that just to find negative 5. Okay. We made it. Last problem. Let's go. What are we doing here? Graph the same parabola as you did in number 27. Okay, so are they the same ones? Yeah, they are. Okay, so basically, graph it again. Sorry. Get my points. I'm just going to graph it real quick. So 3. I'm not going to put the axis of symmetry. Okay. So here it is. There are the points that we found. Graph it. Kind of nice like. All right. Okay, so what's about to happen? What do you think? Now, it's an inequality. So this guy right here, it's not equals to like it was in the last problem. Okay, so here's something to remember. Okay, when it's strictly less than or greater than, it's a dotted line. So what does that mean? That means right now, I drew a solid line. So less than or equals, greater than or equals, solid line. So what do I need to do? I need to make this a dotted line. All right, I made it. There it is. It's dotted. Okay. I got a shade either in here or out here. We have to figure out which one is it. The way you do this is as follows. You pick a point somewhere on this graph. I like to choose 0, 0. Right? It's the easiest to work with. The reason I'm choosing 0, 0 is because x is equal to 0, y is equal to 0. So I'm going to plug these numbers in to the original equation and see what happens. So I'm going to get 0 is less than -2 times 0 plus 2 is just 2 squared plus 3. Right? This is what I'm doing. I'm plugging in zeros in for these. So I'm getting 0 is greater than, all right, so let's do this correctly. 2 squared is 4. 4 times -2 is -8 plus 3. So 0 is greater than -5. So then once you get to this point, you ask yourself, is this true or is this false? Is 0 bigger than -5? That is 100% a true statement. 0 is bigger than all negative numbers. So now, don't associate true with outside or inside. What I want you to associate true with is if it's true, you shade on the side that has the point. So what side has the point? The outside has the point. Does it always have to be that way? No, but it's like that right now. So I'm shading outside because this is the side that has the point. Yes. All right, the next step is that we're going to graph the linear line. So I'm going to use a different color. So here we have y less than or equal. So right now this is a solid line. Oops, the heck. Here we had dotted. Okay, the y-intercept and then the slope. So it's going to cross at -3. Y equals -3, which is just outside of the quadratic. And then down 1 to the right 1. And then keep the pattern going the other direction. Does it look funny? All right, and the line is solid. So then do we shade above or below? That's the next question. So then 0, 0 is above the line. So let's see if it's true. If it's true, I'm going to shade on the side that has the point. Okay, we can answer some questions here. What is the slope? Slope's -1. What's the y-intercept? -3. All right, too easy. Okay, so let's see. Are we shading above or below? That's the question. So 0 less than or equal to 0 minus 3. Is 0 smaller than -3? No, we just said bigger, or 0 is bigger than all negative numbers. So this is false. So I do not shade on the side that has 0, 0. I do not shade on the side that has 0, 0. I have to shade on the other side. So okay, there it is. The solution lies in the overlapping parts. Remember, overlapping solid area. Overlapping solid area. And on a solid line. All right. Hopefully this helped out somebody. Have a good weekend. Good luck.